Okay, the last quiz gave a little bit of difficulty, quite a bit of difficulty actually, and I know some of you struggled with it. So I want to try to clear up some things that I think people had problems with. From what I saw, and based on that quiz and especially some of the quizzes earlier, as far as what you understood and what you didn't understand, the basic ideas and concepts that we've been talking about, a lot of you actually have pretty good grasp of. You know, the inscribed angle theorem, quadrilateral, inscribed quadrilateral theorem. It's new, but people are getting that. But some of the things that people are having more trouble with have to do with when you're trying to find the answer to a problem where it requires indirect use of one of those things. Now, when I say indirect, what I mean is, something that's going to take 2 or 3 steps. So if you have, let me give you an example here. So if the question is, okay, find ED, measure of arc ED, then you look at the question, you say, okay, what do we have? Okay, we have a 60 degree here, that's an arc measure. We have 50 degrees here, and ED is this one right here. Okay, we'll highlight it. So there we have a theorem. The theorem says that if we have an angle that's inscribed, it's inscribed if the vertex is on the circle, then the arc that it intercepts, which is this one, is going to be twice as big. Okay, or you can also write it as saying the arc and the angle is half as big as the arc. The relationship's the same, right? So we take this times 2, so we say 50 times 2 gives you the measure of arc ED. Well, that means the measure of arc ED would be 100. So we used that theorem, only that theorem, and we didn't have to do any kind of adjustment or whatever. So that we found that directly. So where it becomes more difficult is if we ask something else, like for instance, one of the questions was find the measure of arc CD. Now CD goes from here to here. And if we try to use the same exact theorem, we see this number right here, but this angle goes with that arc. CD would go with the angle that it's intercepted by. And here we see it's not even, here's an angle that it intercepts. So this angle right here goes from one part of the arc to the other part of the arc. So this is the angle that matches up with it. Okay, that's the angle that it matches up with. But unfortunately, we don't have a number here. We don't know what this angle is. So we have to find some other way of doing it. And this is where using the things that we know indirectly comes into play. We're going to have to use more than one thing. So before you even start a problem like this or any other problem, you should be kind of keeping in mind all of the things you know. And so you won't use everything on every problem, but you should be thinking about all of these and asking yourself, which ones do I need? So some of the basic stuff that you know, if you have a whole circle, we're talking about arc measure right now, a whole circle, 360 degrees. Okay? If you have a half circle, called a semicircle, right? Well, half of 360, so instead of going all the way around, you only go halfway around. That's 180. We know the diameter, if we see a diameter, then nobody has to tell us that it's a half circle. Okay, the diameter cuts off a half circle or a semicircle, right? So there's a semicircle, there's a semicircle. Okay. What else do we know? And I'm going to write down a list, and I might forget some things, but I'll have everything we need for this problem for sure. So if we look at inscribed angles, okay, there's an inscribed angle. Okay, what's it equal to? 1/2 of the intercepted arc. So in other words, 50, that one's going to be 100. So, and if we go the other way around, 50 is half of, twice 50 is equal to 100. So if we take the inscribed angle and then we multiply that by 2, we get our intercepted arc, right? Okay, so these two are the same thing, they're equivalent. If we take one arc, let's say RS, and then we have another arc that starts in the same place, as this one leaves off, and then we add them together, our result is going to be the whole arc. So RST. And when we look at that, we're talking about the measures, right? So the measure of RS plus the measure of ST is the same as the measure of RST. You can put it together. Okay. And then the last one for now is our inscribed quadrilateral theorem. Okay. Now, even though there's a quadrilateral here, we're not going to need this one here. We're just finding this arc. So you want to go through here and ask yourself, do you see anything that can be used here? And the first thing I see is I see this diameter that's going across here. Here. Maybe I shouldn't be using yellow on yellow paper. So we look at this diameter, and that's what we have, right? Where you have a diameter, we have a semicircle. So here's our semicircle. That tells us something about EDC. We know the measure of EDC has to be equal to 180, right? But we're trying to find CD, which would be the same as, CD right here is the same as DC. The direction you go doesn't matter. So we have 180 degrees all the way. And the drawing isn't very, very good, but if you go 100 and then the whole distance where the whole measure is 180 and you've gone 100 already, what's left over? So, the point is, if we know this right here, this is true, can we use it? Measure of ED, then it leaves off here, plus DC. What's that going to give us? Measure of EDC, right? Well, what's the measure of EDC? 180. What's the measure of DC? Well, we don't know at this point. What's the measure of ED? 100. Okay, so 100 plus this number, whatever it is, has to be 180. Well, what is it? There's the answer. Okay, so one of the things that's important, like I said, make sure you keep in mind everything you know. You could have something like this with everything written down on a separate piece of paper that you check back to sometimes, or if it's just something that you think about it. But as you're learning these things, and if you don't have them memorized, just have a piece of paper like this, write them down. And then on all your problems, you say, well, what do I need here? Do I just need this? Or do I need more than one? What kind of a problem is it? Is it one where I can find the answer with just one step, like this one step? Or do I need more than one step, like this one? Okay, so here we needed, what, 3 steps, right? Okay, we need to know this step first, which we did on this problem. Then we needed to know that this is 180. That's our second step. Then our third step was to apply the arc addition postulate. So 3 steps. And of course, as you add more and more and more steps, it becomes more complicated, even if the individual parts or steps aren't any more difficult. So I think that's a big issue that people were having trouble with. And I'm going to try to keep this short. So I'll end this video now, and then I'll make another video you can take a look at also if you have questions on some of the other problems.